So here we have input, ground, and output. So I can just put the read probe in the ground, okay? The read probe in the ground and check between ground and input. As you can see, I get a value. This is not a diode, this is a value 557. So if I move the black probe to the output, I should get a double value. So let's check. As you can see, 1190. The red probe in the source and the black probe in the drain, because this is N-channel MOSFET. So let's put the red probe in the source, as you can see here, and the black probe in the drain. I should get a reading about 400, 500, 600. As you can see in the multimeter, I get the reading because this is N-channel MOSFET. Hi, in this video I'm going to teach you step by step using the multimeter how to test power MOSFET, transistors, voltage regulators, pulse width modulation IC or power management ICs, optocouplers or opto-isolators, bridge rectifiers, Schottky diodes, and much more. And of course, I'm going to teach you how to identify the type of these ICs. Because this one, for example, is it a transistor, a MOSFET, a voltage regulator, a Schottky diode, or what? Based on what we can identify whether the component is a transistor, MOSFET, etc. So this is a free course where you will learn everything about how to test electronic component, especially the component with 3, 4, 5, and 6 terminals. So please go with me step by step and follow with me until the end of this video, and I will guarantee for you that you will be a pro on electronic component testing. So let's get started. But first, don't forget to subscribe, share the video with other people like you, and like the video, because your engagement really motivates me to create more and more videos for you. Thank you very much. And for anyone who want to join me in the Patreon page, you are very welcome. So let's get started. So here we have basically main component, as you can see here. We have MOSFET, transistor, etc. So this one, for example, and this one, as you can see, they have the same shape and the same number of terminals. 3 terminals, 3 terminals. Okay? This one also has 3 terminals. This one also has 3 terminals, as you can see. So how can I identify these ICs? This one, this is MOSFET, this is transistor, this is voltage regulator, and this is an IC, a pulse width modulation IC that is used in switch mode power supply. So I cannot begin and test the component without knowing the type of component. For example, this is voltage regulator. I cannot test it using the same working principle as transistor. Wrong. Okay? So the first step is to know about the type of the component. Okay? So we can know about the type of component using basically 2 methods. By experience, for example, for me, when I say this number, as you can see over here, so K2611, the component that began with this number, for me, based on my experience, is always MOSFETs. Okay? And others, for example, that began with D24, as you can see, like this one, is transistor, not MOSFET. Okay? So, based on reference, for example, this type of, as you can see, component, as you can see over here, this is bridge rectifier, because here, as you can see, we have plus, minus, and we have EC symbol here. So this is simple. This is bridge rectifier. Okay? So, and other component like this, where you find 2 diodes, as you can see, like this one. where you find two diodes connected together like this one. So this is a Schottky diode or a rectifier symbol. Okay. So for example, here I have many components here. Okay. How can I see? I know whether this is transistor or MOSFET, etc. So based on two methods. So the first one is by experience. You know, using your experience, the references. The second one is to use the internet. Simple. I will give you a website, a very important website that I use in a daily basis, that provide me with all information about any component I want. So based on this simple website, the type of this IC. If you don't have enough experience on identifying the type of IC, you have to use this website. Basically, there is many websites, but for me, I prefer this website. For example, this is MOSFET. Okay, so let's confirm whether this one is MOSFET or not. We have K2611. I will show you this website in the computer and how you can find the type of the IC based on its reference. After that, I will use the multimeter to test all these components one by one. Okay, so let's go to the computer. So here, as you can see, let's go to Google, for example, and just as you can see over here, we have K2611. So let's write K2611. Okay, and just press enter. Okay, let's pick the first result. As you can see here, basically this is the website over here. We have alldatasheet.com. This is a very important website that I use in a daily basis in order to find the type of component. So here, as you can see, we have K2611. So I can just go here. As you can see over here, we have K2611. So this is a silicon N-channel MOSFET. Okay, so I confirm that this component is a MOSFET. Okay. And I know here that this is N-channel MOSFET, not P-channel MOSFET. So if I want to download, for example, the datasheet for this MOSFET, I can just go here. This is the PDF file where we have, as you can see, 7 pages. So let's click over here and then go here. We have download and click K, the part number of the component. And as you can see, here we go. Okay, so we have the MOSFET. So I confirm that this component is MOSFET. Okay, we have MOSFET, we have gate, source, drain, and of course you can read about it, its characteristics, and of course the function, block diagram, etc. Okay, if you want to download it, you can just click over here in this icon and go here. As you can see, we have a security code for 21290 and press download, and as you can see, here we go, the file is downloaded, and then you can open it and read. As you can see, we have the file over here. So you can use this working principle for all components. So now here for this component, this is the MOSFET. So once I identify that this component is the MOSFET, then I can test it using the multimeter. Okay, so this is the MOSFET. I can test it using the multimeter and using the right method to test the MOSFET. So because this is the MOSFET, so I have here, as you can see, so this is gate. Okay, here we have drain and here we have source. If we go to the file, for example, so I upload the file. So let's go and check the file over here. So here we have gate, as you can see here, drain, source. Okay, so gate, drain, source. So now I will use the multimeter to check whether this MOSFET is good or not. So of course I will choose the diode option, as you can see. Okay, I will choose the diode option and then press the power button. So let's check. first thing to do is to connect between these two pins and these two pins in order to discharge the MOSFET. So let's test this MOSFET right now. So we know that this MOSFET is N-channel MOSFET. So the diode, as you can see here, is between source and drain, and the anode connected to the source, the cathode connected to the drain. Okay, so I will find a reading when I put the red probe in the source and the black probe in the drain, because this is N-channel MOSFET. So let's put the red probe in the source, as you can see here, and the black probe in the drain. I should get a reading about 400, 500, 600. As you can see in the multimeter, I get the reading because this is N-channel MOSFET. But if I swap the probes, as you can see, I will not get anything in the multimeter. As you can see, nothing in the multimeter. Also, between source and gate, nothing. Between drain and gate, nothing, as you can see. So the only reading is between source and drain, and when I put the red probe here and the black probe here, because this is N-channel MOSFET. Okay, so this is it for this one. Let's see another one. This time we're gonna see a transistor. Okay, so let's put the MOSFET here. Okay, so here we have transistors. Basically, for me, I know, based on the part number, I know whether this is a transistor or a voltage regulator or MOSFET, no problem. But for you, the first time, you should use the part number. So what is the part number here? We have D2499, as you can see over here, D2499. So let's go to our website and put this part number and check whether this is transistor or not. So here we have the part number. Okay, by the way, using this website, you can search using the part number, using the description, or the marking. For example, the description, if you don't know the part number, or if you cannot read the part number. For example, if you cannot read the part number is missing here, you can use the description. For example, use here N-channel MOSFET. Okay, especially for example 30 volts MOSFET, N-channel MOSFET, or N-channel 30 volts MOSFET. Okay, and then the website will give me all MOSFETs that has the voltage, the maximum voltage of 30 volt, okay, or 28 volt, etc. But the best way here is to use the part number. The best way is to use the part number. So let's go back to our component. Here we have D2499. So let's put D2499 and just hit enter. As you can see, here we go. So here we have D2499. So this is NPN. Okay, this is NPN, triple diffused mesa type horizontal deflection output for color TV. Okay, we don't have here enough information. Okay, this is NPN means transistor, because for MOSFET we have N channel or P channel, and for transistor we have NPN or PNP. Okay, so let's see this file. Also we have silicon diffused power transistor. As you can see here, we have power transistor. So let's choose this one, because also this is transistor, NPN transistor. So let's, here we have 5 pages. As you can see, we can just click over here in the PDF file and go here, download, and click again the part number, as you can see. So let's see, here we go. We have here, as you can see, Toshiba transistor, silicon NPN triple diffused mesa type. So this is transistor, as you can see. Okay, here we have transistor, here we have base, collector, emitter. Okay, here the first pin base, collector, emitter. So this is transistor, not MOSFET, not voltage regulator. So this one is transistor. So now I can test it because I know that is transistor. So let's test it. Let's put it here. So here we have, as you can see, we have base, okay, base, okay, then collector, then emitter. Okay. So now let's use our multimeter, and of course using the same working principle we're gonna select the diode option because the transistor contains diodes inside it, and just press the power button. And of course here we have base. Using the same working principle, let's discharge this MOSFET. Okay? Because when you touch the base or the gate of the MOSFET with the red probe, you will get a wrong measurement. Okay? So always try to discharge the transistor and the MOSFET and then test it. And I know that this transistor, as you can see, is NPN, as you can see here, NPN transistor. Means, as you can see here, we have here P. So means, as you can see, NPN. So let's check. Oh, we got a buzzer. Here we got a reading. Here we got a buzzer. So let's discharge again this MOSFET. Let's discharge it. Okay. Okay. So let's check again. So let's put the red probe here. We get a reading between base collector. So let's check between base emitter. We get a buzzer, a low resistance. Here we get a reading. Here we get a low resistance. So let's discharge again this MOSFET. Okay. So let's begin with the black probe here and the red probe here. We get a reading. Here, this is right reading. Here we have a short circuit. Means this is a transistor, but unfortunately this transistor is a bad one. Okay, so this transistor is a bad transistor because we get a short circuit between base, as you can see, and emitter. Between base emitter we get a short circuit. Okay, we get a short circuit. So this one is a bad one. This is a good one. Okay, so I can't test this others, but I don't want to make a very long video, so let's pass. We gotta just test one component here, one here, etc. Okay, in order to avoid making a very long video. Okay, so here basically we have voltage regulators, but first, if I see this component, I cannot know whether this is a transistor or MOSFET. But if I look to the part number, for me, based, as I told you before, based on my experience, so for me, based on my experience, I know that 7812 CT is a voltage regulator. But let's check using our website. Okay, so here we have 78. Okay, so this is basically its part number is 7812 CT. So this is the part number. Okay, 7812 CT. So let's go to our website. Okay, here we have part number. Let's erase here and just write 7812 CT and press enter. Let's see. Here we have the same part number 7812 12 CT, we have 16 page for this part number, and this is 3 terminals, positive fixed voltage regulator. As you can see, this is voltage regulator. So if I want to check it or to test it using the multimeter, using the same method I used to check the transistor, wrong. Using the same method I used to check MOSFET, wrong. Why? Because this is voltage regulators. It doesn't have base collector emitter or gate drain and source. No, it has input, output, and ground. Let's see the schematic. So here we have the PDF file, 16 page. So let's download it. Here we have download. Let's click again the part number, and here we go. We have, as you can see here, the PDF file. I can even download it. Let's click here, this icon, download. Okay, and go and enter the security code. So we have 61752, and just click download. As you can see here, so the file is downloaded. Okay, so let's open the file. Here we go. So here we have 3 terminal positive voltage regulator. As you can see here, if you focus here, so let's remove this. So as you can see, if you focus here, let's zoom a little bit. Okay, good. Here, this is basically voltage regulator. So we have here many part numbers for this voltage regulator or series. So we have the pin 1, 2, 3, not collector, emitter, and so on. No, 1, 2, 3. So the first pin is input. The second pin is ground, and of course the second pin here is connected to the side here. Means this pin, okay, in the middle is connected to this one. We can even check using the multimeter, as you can see. So this is ground. This pin here, as you can see here, in the schematic, pin 2 is ground. This also should be ground. So let's check using the multimeter. We should get a buzzer. As you can see, low resistance in the multimeter. So this is ground. This and this are connected. So here we have, as you can see, input, ground, and over here we have output. Okay. You can find also this type of voltage regulator. Okay. So how can we test this kind of voltage regulator? So basically, to test voltage regulator using the multimeter, you should connect voltage regulator to the motherboard, or just give it the input voltage. For example, if the input voltage is 12 volt, give to this voltage regulator 12 volt here in the input. Okay, here. So here, this is, as you can see, here we have input. Okay, so here connected to the ground, and here we have output. Okay, let's assume that the output is 5 volt and the input is 12 volts. So to check whether this voltage regulator is serviceable or not, you should power it with 12 volt in its input and connect this one to the ground, and then you should use the multimeter to check whether this you get 5 volt or not. So once you feed it to 12 volt and you connect this terminal to the ground, then you can check these 2 terminals like this and get 5 volt in the multimeter. Okay, so this is how you can check the voltage regulator. But I will give you a trick that you can use to test whether the voltage regulator is serviceable, is good or not. So how? So here we have input, ground, and output. So I can just put the red probe in the ground. Okay, the red probe in the ground, and check between ground and input. As you can see, I get a value. This is not a diode, this is a value 557. So if I move the black probe to the output, I should get a double value. So let's check. As you can see, 1190. So here we have this value. Here I should get a double value. Means this is a good voltage regulator. Okay, sometimes you can find a short circuit, means a bad voltage regulator. Okay, so this is how you can check whether the voltage regulator is good or not using two methods. By applying the voltage 12 volt, for example, to the input and connecting the middle one to the ground, and you should check here or get 5 volt. Or by checking using the multimeter, as I told you before, between ground and input, you should find, for example, X reading, between ground and output, X times 2. Okay, so this is for voltage regulator. So let's move on to power management IC. So guys, this video is about 30 minutes. I think that's enough for this video. I will continue into part 3, how to test power management ICs, optocouplers, bridge rectifiers, Schottky diode, and how to identify these other ICs and test it using the multimeter. So that's it guys for this part 2. Thank you very much, and please don't forget to subscribe if not already subscribed. Share the video with other people like you and like the video. Please don't forget to like the video because your likes motivate me to create more videos for you. Thank you very much and see you in the next video.